Hi, I'm John Willis. Currently Senior Director of Global Transformation Office at Red Hat. This presentation is called Security Differently. So, for those who don't know me, and I've done a lot of things. I think now 40 years, 40 plus years in this industry. So I'm pretty old as dirt. Um, Most probably notable is my co-authorship of the DevOps Handbook. Also, a project I did with Gene called Beyond the Phoenix Project. A lot of the things I'm going to talk about in this presentation come from this forum paper, DevOps Automated Governance Reference. And then there's some other papers. I'm going to focus mostly on risk in this presentation. I've done longer versions where I cover identity and defense. But given this a 30-minute presentation, I've done a lot of things, right? I sold a company to Docker, I sold a company to Dell, and like I said, I've been an executive in residence. I was early in at Chef, blah blah blah. Play guitar too. So one of the things, I think at the end of the day, one of the things I sort of enjoy most about my career is I consider myself probably more than anything a student. So I've written IBM mainframe assembler code. I've written Java code and distributed constructs. I've written operators for Kubernetes. And I'm not bragging because I'm not really good. Well, I guess I'm good, but not great at any of that. But my real passion is really being a student of what we do. And to that, I really think a lot about sort of this evolution of moving from different economies, the sort of agricultural economy. In fact, there's a lot to learn from the agricultural economy. Um, Even we talk a lot about industrial economy. We talk about sort of lean or Toyota production systems to knowledge economy work. Anyway, I think there's that's an interesting discussion. And yeah, I don't call it a shameless plug. I mean, it's a plug. I have a podcast I started this year called Profound, based on Dr. Deming's system of profound knowledge. It's sort of not a secret. I'm writing a book over the last year about Dr. Deming, and so I've been interviewing just all these sort of tremendous people. So, if you think anything about Deming or just systems or systems thinking, probably you might find it interesting. So the whole security and DevOps thing really, for me, I could say Josh Corman, and that would be true because Josh Corman has been an incredible mentor to me. But Shannon Leitz has been my sort of go-to mentor in a lot of things. She really is the sort of a security expert. She's no longer into it, but she's the one who coined DevSecOps. And so it's kind of like in DevOps. I always defer to Patrick DePauw. In DevSecOps, I defer to Shannon. She sort of started with this canonical discussion of what DevSecOps is. Um, Over the last year or so, I've been thinking a lot about more than DevSecOps. Again, going back to that sort of student side of me, when we talk about DevSecOps, or for me, am I being sort of intellectually honest, right? Because it's we just sort of banter DevSecOps, and DevSecOps is an amazing thing that has happened over, say, I'll just say 5 years. It's probably been longer. Because we've automated a lot of security things that we hadn't been doing. I mean, I can go on and on about why DevSecOps has been a great discussion, meta framework, whatever you want to call it. But then I question, like we can't just always be patting ourselves on the back, right? About like how great we are. We need to sort of look at like point in time and say, where are we deficient? And so I really started thinking a couple of years ago about what are the things, it's probably more importantly, that I've been passionate about, as I sort of think about DevOps and security. And so this led me to this discussion called modern governance, right? Which is, you know, are the things that we've been doing, even pre DevSecOps, even post DevSecOps, if that's a thing, like for example, automating all these security things in your pipeline, right? That's a good sort of discussion point of DevSecOps. Sort of people come to me and say, John, you want to see my DevSecOps reference architecture? And they've got like SAST and DAST and software composition. Now all those things automated, and that's fantastic. The question I think I try to answer, or I've struggled with through all this sort of DevSecOps discussion, is hovers around like, how do we prove that we're safe? How do we demonstrate that we're secure? And how do we sort of do both? right? And and if I looked at the sort of landscape even today, a lot of organizations I talk to, the proving we're safe is is basically change records. Sally told Bob, who told Sue, who said this, and it's a telephone game, and it really is highly subjective. And how do we demonstrate our secure that we're secure? It's our audits, and those are toil based. So what we have here is low efficacy, subjective attestational data, combined with high toil, very frustrating audit conversations that sometimes last 30, 40 days a year, right? And so one of the things I started thinking a lot about, which was, what if like DevOps never existed and this all the greatness of DevOps started with a DevSecOps conversation. Imagine the security people generally jumped up and figured out a way to do this is all sort of fantasy, sort of meta conversation. But what if that was the case? Well, so I have this sort of square peg round hole thing on the left, right? Which is like we've done great things, but because we were sort of building an abstraction on top of an abstraction, meaning DevSecOps was sort of built on a DevOps mindset, did we basically miss, or were there some gaps in the way we were thinking? And the reason I started thinking more and more about this is, like I said earlier, I'll go into a lot of organizations and they'll say, John, I want you to see our DevSecOps reference architecture. And I'll look and I'm like, that's great. That's awesome. And we'll have a deeper conversation about audit. And I'll hear a lot of discussions about following the 3 lines of defense model. Now, for me, who's somebody who doesn't have to sit in and be responsible for audit, right? Like, I can step back and I can say, hey, all this sounds crazy. This is 3 walls basically. It's if you look at Andrew Clay Schaefer, who's my boss at Red Hat, my friend, my best friend, and he in 2009, the same time John Osbar was giving his presentation on the 10 deploys a day in Flickr, which basically was a landmark presentation. That same day, Andrew gave a presentation called Agile Infrastructure, and he had this picture in there which described what he described as the wall of confusion. What we all know has sort of been a primary meme of what DevOps is about, is breaking down that wall of confusion, right? And when I look at the 3 lines of defense, I just see that same anti-pattern from organizations that purposely try to create silos between the first line, second line, third line. In fact, a lot of organizations use the second line as a buffer, sort of a conversational buffer, right? Like, how well does that work out? And then, and a lot of sort of conversations get sort of, and then there's this sort of catch-all, the like whatever the first line doesn't catch, the second line catches, which is, and looking at from all the way stepping outside and looking in, I would say this is very similar to the problem that we've reasonably solved in the DevOps conversation over the last 10 to 15 years. Right? So that was my starting point for, security different, or something that we might call modern governance. Originally, I was calling automated governance, and Shannon actually sort of told me, don't do it that way. Make it something so it makes people think it is really something different and force people to think differently. And so this idea that we're going to move more from an implicit security model to an explicit proof-based. And I said this earlier about subjectivity versus objectivity. So what is modern governance? How do we think differently? How do we reduce toil and increase efficacy of audits? How do we automate the full process? So, like, again, those DevSecOps reference architectures are good, but maybe not good enough, right? They're sort of, we got SonarQube here, we've got this here, we've got this here. In some ways, we're actually creating more operational toil for both the developers and the auditors. I hear lots of stories where, auditors will ask the question to somebody, why is the SonarQube log different from the Nexus log? Oh, let me explain. Even though I could see how you would think they should be the same, but so we sort of build in, if we're not creating a systems approach to how we're thinking about this, all these sort of point integrations, as good and necessary as they are causing us increased toil. And then talk. The main part of this sort of risk discussion is objective and immutable evidence, as opposed to sort of change records and subjective. Of course, the CI/CD pipeline is anything that has dev connected with sort of ops, dev, SecOps, whatever. We know that's sort of a primitive today. And then there's an interesting discussion I don't really get into here, but if you can sort of get this immutable structure in place where the evidence is not subjective, you have some interesting opportunities to think that maybe sort of error budgeting for risk or just general SRE for risk. And I've talked about this a few times, right? Like, what do we need to do in this case? Act differently. And that is not only changing the subjective to be objective, but I'll also point out that you need to be sort of an ongoing continuous verification. And so I created, if I was good at sort of graphics, I'd probably be good at graphics for a living, but I'm terrible. But, I tried to put this together in a very simple format, which is, how do I look at the things in, and I use this phrase, post-cloud native modernization or post-cloud native world. And I know, like, I always feel like I'm going to get punched in the nose by somebody for saying that, and I still haven't gotten punched in the nose yet. So, but I wanted to draw a distinction from not just sort of DevSecOps or cloud native GRC. Is there was sort of things that in a post-cloud native way you do things, I felt that these things were maybe a little more important and a little bit should be sort of pointed out, and then using the subjective to objective and verifiable as a model. Like I said, in this presentation, I'm going to mostly focus on risk, but I will go through the three of them here. So in risk, the subjective we talked about, it's the sort of change record, it's the ServiceNow record, it's the sort of Sue tells Bob who tells Jane who does this, and then Jane puts even in some cases a checklist. Yes, I did this, I did SCA, I did DAST, I did, but it's really not. So first off, it's human created. Second off, it's basically not immutable, of course, and it's not really purely digital. And then, so we want to change that into a model, which we'll get into here a little bit, of sort of where the attestations and the control points are non-human. They're digitally signed events, and they're immutable. But even that's not good enough, right? Because we know that in all these systems are based, we know that most of the systems we manage are complex systems, or you could argue every system in the universe is a complex system, but that's a different discussion. But certainly the systems that we try to manage in large cap organizations are complex systems. And, so the idea that at any point in time, exactly the way things looks is basically a fallacy, right? So this idea of like, I don't care if I've got all this tight immutable evidence in my pipeline, this notion of continuous verification, which is derived from sort of chaos engineering. And, but it's a more purposeful version of chaos engineering. For example, instead of just blowing up like CPU or blowing up a server or, and finding out the reaction, which is not a terrible thing. This is a very prescriptive, like, let's open a port on an application that should have never been opened, could have never gotten through the pipeline, or let's go ahead and start up a container image with a well-known vulnerable library and see what happens. Let's go ahead and increase latency. Maybe a Kafka cluster will sort of just continually increase the latency and then see what happens, right? And then you can think of the same thing for defense and trust, but again, a lot of what I see now is in defense is moving from just sort of remediation systems, which again, necessary, to intelligent data lakes, and then something Shannon works on, which is like tremendous. I do a whole presentation on adversary analysis, and the same thing with trust. Table stakes today is zero trust architectures, but we need a better model when we have clusters and ephemerality in the way we do sort of just containers or functions. We need what I call sort of an east-west versus a north-south. And again, I've got longer versions of this out there. So let's focus in on risk differently. And so the main goal here is to reduce audit toil, like I talked earlier, and increase audit efficacy, right? So, and how do we do that? One of the ways, or two ways for sure, is to sort of drive towards, so the way we do that is through automated, objectable, and objective and immutable evidence, right? And then we apply this verification because we know everything in complex system has some form of drift. We've worked on, part of Gene Kim's organization, the IT Revolution, which is the publisher for, the Phoenix Project, the Beyond the Phoenix Project, the Handbook, Accelerate, all the great books. We also publish, we do these working groups, we call them forum papers. Every year we produce about 7 or 8 of them. There's usually about 40, 50 people involved. So back in 2015, there was a great publication called An Unlikely Union, DevOps and Audit. These are all Creative Commons. And in 2018, another one, which was like brilliant, which Dear Auditor, which is an apology letter to auditors, but more specifically, it was a discussion about the control regs that we try to do better as an industry. And in 2019, I worked with a team of creating this idea, this immutable, non-human attestational data in a pipeline. So that's called DevOps Automated Governance. And a lot of that came from discussions I had with one of the authors of the DevOps Automated Governance book is Topal Pal. While he was at Capital One, he basically did tremendous a lot of sort of knowledge sharing with the industry, and they wrote a 2017 paper about how they design pipelines, and they talked about these gates. So we had talked about, if you had these gates, could we actually turn those gates into attestational data? And at first we sort of toyed around with the conversation about maybe blockchain, and then that we realized that's probably too heavy of a hammer. So I always like to say, when you think about this model I'm talking about, think blockchain, do not use blockchain. So unless you find a good way to do it. Yeah, a little bit more about this, the Capital One focusing on the DevOps pipeline. Like I said, it was created in 2017, and it was really, it was sort of the starting point for a lot of conversations Topa and I had, and then some of the other people, John Rezatowski, today he's over at PNC, and Courtney Kissler, and then a few other people that I'm not coming to the top of my head right now, but the Dwayne Holmes, who was at Marriott at the time, and who else since I've gone, everybody else, let's make sure I got, I think that was the core group. There were definitely other authors, but one of the things that sort of started 2 years early in this conversation was this idea of this how Capital One did their pipelines. Now, a lot of people were doing this very similar thing. They just came out and gave a really good sort of overview of they called them the gates, and they were like these 16 gates. And like, in other words, in order for you to be able to get an authority to deliver software, right? Everybody's trying to get out of the cab, if you will. In order to get sort of an authority to bypass for not all applications, but certain applications or services, you had to show evidence that you could make available this kind of information that could be gated, like source code versioning, optimum branching strategy, static code analysis, maybe a percentile of code coverage, all these things, vulnerability scan, artifact version control, auto provisioning, all these things. And the conversation evolved into, if we're gating these things, could we actually be creating digitally signed evidence of these same things and actually store that in an attestational database and ultimately an immutable attestation status, so you could show auditors that you don't have to sort of go through screen prints and email exchanges about like what something said in a change record. Anyway, that was really what set the foundation for all the discussions that we had regarding that. So the idea of that publication in 2019 was to break down the sort of software, the pipeline, into 7 stages, and the primary breakout was due to how do we create control, gates, and attestations. So what was the logical boundary points? And so this is what we came up with, and then a gentleman I've been working with for the last year and a half at Red Hat, who has done tremendous amount of work with the government, the DoD in a lot of these areas. He pointed out something really cool that we didn't have in the book, which was, he calls it the IOR-CAA, which is the input, output, risk, the controls, and then actors and actions. And so that's, in fact, we have in that guide a really thorough breakdown of all these things. So it's a very educational book. And I won't go through all these, to save time, but over the years, we've sort of compiled more and more better at each stage. So you could look at things like putting an attestation and certainly a control gate on like change size or unit test execution, unit test coverage, or even cyclomatic complexity, right? So these are things you might not even get started with. Was there was there a peer review on a pull request? You know, are you using a mandated or optional branching strategy? You know, and you could look at the sort of build stage, build version, configuration, linting, to a certain sense, SAST scanning, and then you get into sort of package where it gets a little more complex, like artifact versioning. Is the metadata? Are we making sure that the packages are coming from secure, certified um, services or servers, code signing, of course, container scanning, and then, again, on pod, look some other things there. Also, after that first paper, what we realized was there was a great opportunity to create a human readable machine interpretable interface. So a couple of the organizations, after we wrote that first paper, started doing some prototyping with a DSL form of either, originally called policy code, but risk as code I think is more appropriate, where you can put those sort of things that we saw in the previous side into YAML sort of definitions. So again, now you're moving towards the digitally signed evidence of these things, and they are determining the gating of the process. GitOps certainly has a lot to do with it. That's a long discussion. And then earlier this year, we sat down to try to do a version 2. And what we found was it probably made more sense to produce this as a sort of short story. So and actually the story was so good, it's going to be held back and not be published as a foreign paper, and it's actually going to come out as a novel next year. So it's sort of like a Phoenix project for a bank that fails on audit. It's fun stuff. So stay tuned. I did do some work along the way when a friend of mine had mentioned that they had an opportunity to present to SolarWinds about how SolarWinds got breached, not how everybody else got breached. And would I give a presentation on automated governance to the executives there? I did that. I looked at the kill chain from the CrowdStrike blog, which they probably had the best one out of all of them. And I'll make these slides available, so, just to save time. But the key message here was there were a bunch of things in that kill chain that would have been table stakes for automated governance, like code signing. So there were mismatched code signs in the SolarWinds. Sort of basically what they did is they got into their Jenkins system. They didn't really have good lockdowns, and they basically sat for a very long time, 18 months from what it sounds like, to watch MS build and be able to sort of hijack it, right? And so like things like code signing mismatches, they also masqueraded logs. So like an immutable sort of attestation system would be, I would say, impossible, but very least difficult. And so at the end, some of the things that I think are interesting here, again, this is sort of my one and only sort of Red Hat slide. There's certainly lots of other solutions, but we've got, because the other thing about Red Hat, like I don't feel guilty of talking about a vendor's product that I work for. They pay me, and I think the product is good. But I mean, we add one more sort of ingredient here: is everything we do here is open source, right? So Plygos is an interesting. I'll show you that. SigStar is really, really cool. Really building on SigStar. And then there's some, sort of commercialized versions of Kubernetes, our compliance operator. And then last but not least, I am an advisor in all transparency of Verica. And so there's some friends of DevOps that are the founders of that. In fact, the principals, and they are really exploring this continuous verification. Just want to show you Plygos. It's an interesting abstraction for how to create an interface definition for your pipeline, sort of a pipeline as code, but much more. And then Bill Bensing, who's been sort of my partner in crime for the last year and a half at Red Hat. He was the first person I found in Red Hat. It was not trying to indict Red Hat, but he was really interested in this idea of automated governance as much as I was. So we're just trying to create, very free and open. We're not trying to make any money off of it. So we created this website to testify. We'll see where it goes. And Bill has put a couple of sort of projects together there to see. You'll see what the sort of initial interest is here. And so anyway, I wanted to thank you so much. My name is John Willis, J. Willis at Red Hat, or Twitter on botchgloop or botchgloop@gmail.com. And again, don't forget to check out my new podcast called Profound. It should be easy to find on your favorite podcasting delivery system. Thank you very much.
My name is Jim Weir. I've been with Accela about 4.5 years. It is at Accela that I have pivoted into the field of DevOps and started to build my expertise in that area as well. Maybe one of my favorite aspects of what I do is to help other developers become unblocked in their work. That's often more rewarding than anything I would do for my own work. Accela works with our government clients every day to push the envelope of DevOps and cloud architecture engineering. We are using the latest AWS technologies to build out some cutting-edge cloud-native solutions for our clients. I would love to talk to you more about that in our virtual booth.
The promise of the cloud is speed and agility. But as enterprises move to the cloud, networking architects and engineers find it isn't the nirvana they expected. They uncover security challenges, networking limitations, lack of network visibility, and manual processes. That's why we created Aviatrix, a cloud network platform that combines the simplicity and agility of the cloud with advanced networking and security capabilities enterprises require. Today, over 550 enterprise customers use Aviatrix software for their cloud network, whether just running in AWS or multi-cloud environments that include Azure, Google, Oracle, and Alibaba clouds. Is your network ready for multi-cloud? But seeing is believing. To get started, simply find us on any cloud marketplace or speak to one of our Aviatrix solution architects.
Hi, DevOps Days, Washington, D.C. We're happy to be here with you for this great event. Chef has been helping to drive the DevOps revolution for more than 10 years now, and if you haven't tried Chef lately, you'll be amazed by some of our latest innovations. With the introduction of Chef Workstation, we've made infrastructure automation and system compliance easier than ever. We've added new resources and tooling that make the Chef experience for developers lighter, simpler, and more powerful. So if you're still using Chef Workstation's predecessor, ChefTK, now's the time to upgrade to take advantage of these great workflows. More recently, we've embedded inspect compliance profiles into cookbooks that, together with policy files, make the whole Chef compliance phase straightforward. Over the past year, we've continued to enhance Chef Automate Dashboard, our go-to tool for managing your system at a glance. Chef is innovating rapidly, and we're proud to be part of the DevOps journey.
Hello everyone, and thanks for joining me today for my talk on OpenTelemetry, the future of observability data collection. I'm very excited to be here with you, and before we begin, let me introduce myself. My name is Frank Reno, and I lead product management for data collection at Sumo Logic. I also serve as Sumo Logic's open source ambassador and work on all of our open source initiatives. I've always found data collection to be a fascinating area of working at Sumo. Collecting data is a critical first step for all the solutions we build for our customers. After all, to observe the health, performance, and security of your applications, you must first collect all of that relevant data. And it's also an area that has seen some significant activities by the open source community over the years, which is completely changing the landscape of observability as we know it. As a product manager, it's really an inspiring space, and as Sumo Logic's open source ambassador, it's been incredible to see the change that open source has driven in data collection and in observability. Today, I want to take you on a journey through data collection over the years. I will share a bit on how it has evolved and been disrupted. To understand OpenTelemetry, it's important to understand how we got here in the first place. We will talk about how OpenTelemetry has changed observability and why it can benefit you. In today's digital transformation journey, observability has emerged as the hot topic. And while it might be a new term, it's certainly not a new idea. It's all about the ability to understand how your systems are behaving to ensure you can meet your reliability needs. To make sense of troves of telemetry from every layer of the stack. The ability to capture, analyze, and correlate all of your machine data is critical to ensure you can meet your reliability objectives. Every level of the application stack emits logs, metrics, traces, and metadata. From your end users to your applications to your infrastructure, you have a wealth of data you need to make sense of to achieve observability. You're in this constant loop of monitor, diagnose, and troubleshoot, ensuring that you can detect the known and unknown application reliability issues, alert on them in real time, identifying the service or the components that are impacting application reliability, uncovering the root cause of those application reliability issues, restoring the service and remediating, and of course, optimizing your application to ensure that you don't have a repeat offender of those same issues later. The collection of all of these signals is the first step of having an observable system, and it is critical to your ability to monitor, diagnose, and troubleshoot all of your applications and your infrastructure. For many years, vendors provided proprietary agents to collect all of this data. Many of you probably had, perhaps even still have multiple vendors' agents running in your infrastructure, each gathering, enriching, and shipping data off to numerous vendors. All vendors in this space really started this way, and for many years it was the standard of data collection. Next came the emergence of open source agents to collect data. With the backing of a large, vibrant community, these agents quickly grew in breadth of integrations and the features that they offered. Leveraging open source agents for data collection gave you the freedom of choice. You could choose which technologies to standardize on for data collection, and you could leverage that stack to send data to the vendors you wanted to. Over time, every vendor supported these agents. While the shift to open source agents and standards brought many benefits, it also brought a few challenges. There was not a single framework or standard for all the critical signals of observability. In order to collect all logs, metrics, and traces, you had to adopt multiple tools. FluentD and FluentBit for logging, maybe Prometheus and Telegraph for metrics, Zipkin or Jaeger for distributed tracing. Adopting multiple tools meant more things to learn, and it created a lot of fragmentation, which in the end created friction when standardizing on open source data collection. We're now seeing another shift in data collection to address all of these challenges. OpenTelemetry is becoming the gold standard to collect all of your machine data, and is changing observability as we know it. Instead of learning multiple technologies to collect all data, you can leverage a single cloud-native framework to complete your observability picture. A single framework that's built on open standards. OpenTelemetry is a cloud-native computing foundation incubating project with quite a history. It was born out of two other projects, OpenTracing and OpenCensus. OpenTracing became a CNCF project in 2016. It was actually the third project to be hosted by the foundation. It provided an API for integrating distributed tracing into an application by providing a framework for distributed context propagation. OpenCensus was a project that was made open source by Google in 2018, and it was a vendor-neutral open source library for metric collection and tracing. Both of these projects were working towards the common goal of developing an industry-wide standard for software instrumentation. As our architectures have grown more complex and distributed, the ability to correlate different parts of the system together was crucial to observe the health. Common instrumentation and the ability to propagate that information is a very powerful tool in achieving observability. Both projects were solving the same problems, and this led to users having to choose which to standardize on. The simple problem here was a classic competing standards problem that I'm sure you're all very familiar with. Having two similar but not exactly identical projects created confusion for developers looking to instrument their apps. It created friction, and both projects recognized it was going to hinder usability and adoption. So to reconcile this conflict, in 2019, both projects merged to become OpenTelemetry. One project with one goal: define an industry-wide standard for instrumentation and collection of all telemetry to observe cloud-native distributed applications. OpenTelemetry is a collection of tools, APIs, and SDKs that you can use to instrument, generate, collect, and export all of your machine data. OpenTelemetry gives you visibility into every layer of the stack and consists of three primary components. The specification defines the cross-language requirements for all implementations. It consists of an API to generate your observability data, an SDK that provides the implementation of that API, and the ability to export the data, as well as the semantic conventions and protocol of OpenTelemetry. The collector is a vendor-neutral way to receive, process, transform, and export data. It is a single agent for all observability data, including logs, metrics, and traces. It removes the need to run multiple agents to support data collection that's leveraging open standards. The collector is also architected to make it easy to extend and to create additional distributions of the collector as needed. OpenTelemetry users and vendors can build optimized versions of the collector while still leveraging all of the great standard features that they need. Instrumentation libraries let you integrate your applications with OpenTelemetry. They provide support for multiple frameworks and languages today, with more being added all the time. In addition to supporting manual instrumentation, many also offer auto instrumentation. Metrics and traces are supported for instrumentation today, with logs support coming soon. These three components provide you with a robust framework to step up your observability game and are really disrupting observability as we know it. By providing a comprehensive, vendor-agnostic framework to collect logs, metrics, and traces, OpenTelemetry ensures you have visibility into every level of the stack, from the infrastructure to the application to your end users. OpenTelemetry gives you comprehensive visibility into the health and performance of every layer. OpenTelemetry is portable. It's built on open standards, and that gives you choice. You no longer have to leverage proprietary agents or a complicated set of multiple tools to achieve observability. It also puts you in control. You're in charge of your data and you have complete control over it. OpenTelemetry lets you build robust pipelines to have complete control over the data collected, any transformations to it, and where it should be delivered. It contains a rich set of capabilities to ingest, transform, and ship data. And finally, it's supported by everyone. OpenTelemetry is supported by every major cloud provider and vendor in the observability space who are all active contributors to the project. As consumers of open source software ourselves, we recognize the importance of giving back to the community. Sumo Logic is an active contributor in many areas of the OpenTelemetry project. We're actively engaged in the logging SIG and actively contributing to multiple areas in OpenTelemetry, including the OpenTelemetry collector. Now, I could talk about OpenTelemetry and data collection all day, but maybe it's best that I just show you how all this comes together to create a really magical experience. In this demo, we are going to leverage OpenTelemetry to collect a comprehensive set of data for my coffee bar application. This is a distributed microservices application that I'm going to run in AWS Fargate. The app consists of multiple components all working together to power our coffee shop. First, let me go ahead and use the SAM CLI to deploy the application. Now, OpenTelemetry Collector comes in three general flavors. OpenTelemetry Core includes the bare minimum components. OpenTelemetry Contrib is where many contributions of receivers and processors and exporters live. For example, vendor exporters live in the Contrib collector. And you also have vendor distributions, and these are typically built on top of Contrib and may add or remove components to work better with that vendor. For the purposes of this demo, I'm going to leverage Sumo Logic's OpenTelemetry distribution. However, all the config we're going to walk through is standard OpenTelemetry configuration, and nearly all of that config can be copied and pasted to any flavor of OpenTelemetry collector. My application is going to deploy the collector as a sidecar right alongside my task definitions, and with this is coming up, let's go ahead and dive into the OpenTelemetry configuration file. So here is my OpenTelemetry config file, and we're going to use this to collect all the telemetry in my coffee bar app. Now, a typical configuration file will define extensions, receivers, processors, exporters, and the service. Let's start with extensions. Extensions are used primarily for tasks that do not require access to the data pipeline. For example, health checks or perhaps integrating with a third party. Now, we have two extensions configured here. The file storage extension can persist state to the local file system, and this is useful when we're using the file log receiver to read log files so that we can preserve where we are in reading in the file. This way, if the agent's restarted, it will know what data it's already processed. This extension is part of OpenTelemetry Contrib, and we include it as part of our distribution as well. In addition, we have configured the Sumo Logic extension. Here we provide our Sumo Logic API access ID and access key, and this ensures that the collector can register with the Sumo Logic backend and send periodic health and heartbeat information. Now, this extension is only available in our distro, and it just enhances the agent management experience for our customers. Customers can and do use pure upstream OpenTelemetry Collector to get data to us as well. Next up are receivers, and receivers are how data gets pulled or pushed into OpenTelemetry Collector. There are receivers to collect all sorts of data, and you can leverage them all. You can even define multiple instances of a receiver to collect from multiple sources of the same type. Here I have 2 instances of the file log receiver, which lets us collect messages from log files. We are using this receiver to capture some of the logs from my application. In each instance, I can define different settings for the collecting data, and we can name each instance to refer to them later in the configuration. In this case, I have 2 different logs from my application that I want to capture. The first is the main application log, which I have named main app, and the second is my audit log, which I have named app audit. Because these are separated into 2 separate receivers with different names, I can do different processing in these streams of data. The ability to name receivers this way, it's not unique to a particular receiver, but it can be used in all receivers and in other components, as we'll see soon. This is what enables us to do some powerful processing later on. Now, my application also emits some logs in syslog, and OpenTelemetry can collect data via syslog, leveraging the syslog receiver. All I need to do is define the listening address and the protocol. Then I can point anything that emits data in syslog at OpenTelemetry Collector. OpenTelemetry also supports the Fluent protocol natively, making it easy to forward data from FluentD or FluentBit if you're already leveraging those today. This lets you easily integrate OpenTelemetry into your stack without having to do too much of a significant lift. Now, parts of our application have been instrumented with OpenTelemetry client libraries for tracing and for metrics. We can take advantage of auto instrumentation in some areas, and of course we have instrumented part of our application for more in-depth telemetry. We can leverage the OTLP receiver to capture all of that data. OTLP is a general purpose telemetry data delivery protocol that's designed in the scope with the OpenTelemetry project. Now, some parts of our application are a bit older, and there we were leveraging StatsD compatible libraries to instrument metrics. This data provides us critical visibility into areas of the application, and we certainly don't want to lose that visibility. Of course, we want to migrate our application to OpenTelemetry client libraries, but we haven't completed that yet. Now, many of you may also have apps instrumented with StatsD libraries, and the beauty of OpenTelemetry is you don't have to re-instrument your applications to leverage OpenTelemetry. OpenTelemetry Collector natively supports StatsD with a StatsD receiver. You can leverage the collector to collect all of your existing StatsD data, but get the benefit of standardizing on a single framework for all your telemetry needs. OpenTelemetry supports many other receivers that we haven't gone through here, and more being contributed all of the time to really expand the breadth of what OpenTelemetry can integrate with. Okay, so now we've gone through the configuration to get data into OpenTelemetry. Now I want to do some additional processing. In OpenTelemetry, we can leverage processors to manipulate, transform, and filter the data that the receivers are collecting. So for example, I can inject some additional metadata into my data. I can do this by leveraging the resource processor. We can add metadata to identify what environment this data is associated with. For example, here I am adding an environment equals to production attribute, so I can easily identify all the data from this agent as production data. The resource processor lets me add, remove, or edit additional metadata, and I can define multiple named instances to have different processing on different streams of data. In this case, I have some common metadata that I want to inject into every signal, like my environment, but I also want to inject some specific metadata into other areas, like my application logs versus my audit logs. Now, OpenTelemetry supports many other processors for different needs. Here, we are also leveraging the probabilistic sampler processor to sample our traces to give us more control over what we export. I can define the percentage of traces I want to sample and fine-tune as I need to. Now that the data has been processed, it's time to ship this data somewhere. And exporters are how you get data out of OpenTelemetry. You can leverage multiple exporters to send data to different destinations. For example, maybe I need to send data to Sumo Logic, but I also want to send it to Kafka for some other consumers. Perhaps you want to just do some quick analysis or debugging, so you want to quickly write the data to a file. OT supports many different exporters to get the data where you need to go. And last but not least is the service section. And this is where the true power of pipelines in OpenTelemetry comes into play. The services section is where you define what components you want to activate and leverage that you've defined above. Unless you enable them here, the components defined are not really enabled. Now I'm going to go ahead and enable the file storage and Sumo Logic extensions here, Just a reminder that the file storage extension ensures we persist our state, we don't lose it in the event of a restart, and the Sumo Logic extension just ensures the Sumo backend knows about the agent for periodic heartbeats and health reporting. Now we can define our pipelines, and pipelines are defined by the type of signal it's for. And like we have seen above, you can define multiple named instances to create multiple pipelines for the same signal. And within each pipeline, we can define the receivers, the processors, and the exporters that we want to use for that particular pipeline. This gives us great flexibility and control over our data, how we enrich or transform it, but also where we want it to go. First, you can see that I have a log pipeline named app, and this is for my main application logs we defined above. Now I've enabled the main app file log receiver here, as well as the syslog receiver, since some of my applications are emitting logs via syslog. In the processors section, I have added the common resource processor to ensure the logs get the appropriate environment tag, and I'm also adding the resource processor for the main app data. Finally, I say that I want to send this data over to Sumo Logic, and so I make sure I activate that in the exporter section. I also have an audit log pipeline, and here you can see that we're pushing in our audit logs that we defined above. Now, I'm able to reuse my common processor to ensure that this data is also tagged as production data, but also add my audit processor for some specific metadata that relates to these logs, as these are my unique audit logs. They're not the same as my app logs. Now, this data is also being sent to Sumo Logic, but in addition, I'm also pushing this data to Kafka for others to consume. For example, maybe my security team wants these logs, but prefers to have them go to their Kafka cluster so they can be routed wherever they want them. Next up, we have the metrics pipeline. And here I'm leveraging the OTLP and StatsD receiver to collect all the application metrics. I also process those with the common resource processor and the main app processor. Now my metrics have the same metadata that my logs do. And this adds the extra benefit of easier cross-signal correlation. Metadata is really the glue between these signals, and now I've enabled easy pivoting between them. And I'm shipping all of the metrics over to Sumo Logic. And finally, we define our traces pipeline. All of our tracing data is coming from the OTLP receiver. It's collecting all the traces that we implemented with our OT libraries. And once again, I leverage the same processors as I did for my metrics and my logs pipeline. And this now ensures that my logs, my metrics, and my traces all have the same common set of metadata that I need them to. Finally, I can ship these off to Sumo Logic as well. Now, nearly all of this configuration that we've worked through is all standard OpenTelemetry configuration. Really, the only unique thing to our distro is the Sumo Logic extension. With exception of that, you can copy and paste this configuration to any flavor of OpenTelemetry collector that supports these components. Let's go back to our application and see if that deployed successfully. Okay, fantastic. Looks like our app is up and running and deployed with the OT configuration we just walked through. So now it's time to see the benefit of all this hard work that we've just put into. The end result is that all of our machine data, all of our logs, our metrics, and our traces from every layer of the stack, wherever we need them to go with a simple, open, and unified collection method. Leveraging tracing data, we can dive into our service map to view the connectivity between our services and get a nice visual of our coffee bar application. We can easily pivot to the traces for a particular service, look at the transactions. From there, we can seamlessly pivot to the metrics for that service and even get into the logs. All of this data coming in is leveraging a single framework that supports a large breadth of technologies, giving us comprehensive telemetry about our applications and infrastructure so we can focus on our reliability needs. I think that OpenTelemetry delivers us a better set of standards for observability. We can move away from separate data collection done in isolation, each with separate data stores that make it impossible to do any easy correlation or pivoting. We can move into a place where we have a unified collection model, built with observability in mind, built to support the cloud native era we're in, and built to make sure that we can meet our reliability objectives. I believe that OpenTelemetry is the future of data collection, not just for observability. After all, the same data we leverage in so many of our operational use cases is the exact same data our security teams are going to leverage for their needs. Different use cases, of course, but the underlying data is the same. OpenTelemetry provides developers with a common standard they can use for all their instrumentation needs. Whether it is manual or automatic instrumentation, you have a single framework to standardize your applications on. You have a collector that's built on open standards that makes it easy to collect data from those instrumented applications. Also a collector that works with all of your new instrumentation and it integrates with all the same technology you're already using. And because we have a single framework with all of this, a framework that puts us in control of our data, we get to prioritize observability and achieving our reliability goals. Thanks so much for listening in today. I hope you enjoyed this talk. I hope some of you will look at how OpenTelemetry can help you supercharge all of your observability needs. Stay safe and enjoy the rest of the conference.
We are almost at the end of this year's DevOps Days DC, and we want to share some well-deserved thank yous.
We want to give one more shout out to our sponsors before we wrap up because they are an important part of our community. Thanks to our platinum sponsors, Excella, Aviatrix, and Chef. Thanks to our gold sponsors, Cloudsmith, LaunchDarkly, Pluribus Digital, and Fearless and Hutch. And thanks to our silver sponsor, HomeLight. Thank you so much to all of our sponsors for being a big part of making this event special for all of us.
And on behalf of everyone here today, thank you to our speakers for taking time from their busy schedules to come and share with us today. Thank you so much for sharing your perspectives, experience, and knowledge with our community and helping to make today so special.
And a huge thank you to the organizing committee. DevOps Days DC is a volunteer effort, and there's a lot of work involved to pull off an event like this. The organizers made it happen and made it special.
And you all do a lot for your communities, from where you live, where you work, to what you're passionate about. Thank you for being a valuable member of our DevOps Day DC community and continuing to share, help, and grow our community every year. Lastly, as some of you know, 7 years ago, Nathan Harvey got a group of like-minded, passionate, local people together and organized the first DevOps Days DC conference. I wasn't actually an organizer that year. I was extraordinarily pregnant with my first child, and a coworker asked me to come because he heard that this conference was going to be really amazing. And I was blown away. I loved that first conference, and I walked up to Nathan at lunchtime and said, I want to learn how to be involved with this community. And he said, okay, let's talk tomorrow after the close and we'll see how involved you want to get. From that time on, not only did Nathan and the rest of the DevOps community welcome me with open arms, they allowed me to become one of the core organizers, and I've gotten to know him over the years. You know, Nathan has led this community through ups and downs. He did extensive research for us by attending other DevOps Days conferences worldwide, and he brought back lots of new ideas and speakers for all of us. And of course, he led the charge to put together the 5 previous DevOps Days DC events, and we would not be here today without him. Earlier this year, Nathan let the organizers know that he would be stepping down as the conference chair and lead for DevOps Days DC, but don't worry. He's still an organizer and participant in our community. He has passed the torch on to Jeff and me, and we will continue to work diligently to bring the best our community has to offer to our yearly conference. Nathan, you have been a tremendous mentor, co-host, and friend to me personally, and your devotion and passion for this community is infectious, and it carries on in all of us. I don't know that I'll ever be happy with what I'm saying here today. Words just can't express your impact to this community, to the organizers, and me. Thanks, friend.
It's going to be tough to follow that one up, but I'm going to try, Holly. I'm going to try. So what's next? Well, our networking event tonight is being hosted by Glenn Wilson, the CTO and founder of Dynaminet. Toucan Events is the platform we're using, and it only takes a few seconds to log in and start connecting. You can get the URL for the event in the reception area. The event starts right now, and we'll leave the event open until 8 p.m. Eastern to allow everyone time to complete conversations and exchange details. Some of our speakers will be in attendance too for you to network with as well. And now one final parting thought, a lesson that we can learn from donuts and croissants. That's right, donuts and croissants. Now, hear me out. Imagine you're at the virtual happy hour in Toucan tonight, and you're engaged in a discussion. You have a drink in your hand maybe, and you're talking with a group about the day. Now, a new person joins your group. Well, how does your group feel to that newcomer? Does it feel kind of closed off and unwelcoming of new conversation? Closed off like a donut? Or is it more like a croissant? More open and welcoming of new people and new topics and new contributions. So the lesson I want to leave you with as we go into the happy hour is don't be a donut. All right. With that, have fun at the happy hour. And if we don't see you at the happy hour, thank you so much for joining us for DevOps Days DC 2021. Until we see each other again,
Be well.
stay safe and take care, everybody.
Take care, everybody.